I am the author of Terraform in Action, and today I'm going to be talking about one of the new chapters in my book, Chapter 12, and it's about secrets management with Terraform. I think that secrets management is a really big deal, especially because there's just so many secrets that Terraform deals with, and this is a really hot topic that everyone wants to know about, but no one's really taken the time to consolidate, which is what I have aimed to do in chapter 12 of this book. I've always tried to break things in Terraform to see what is possible, how can secrets be leaked, where are the potential avenues for attack from a hacker perspective. And so what I've put together is a list of ways that you can be aware of that secrets can be leaked, and also ways to protect yourself from happening to you. Now, just in case you think that there's no possible way of your secrets ever getting out there in the open, I'm just going to remind you of a very famous case that happened a few years back with the Hillary Clinton emails at the Democratic Senatorial Campaign Committee, in which over 6 million emails were leaked. And this was due to something as simple as a S3 storage bucket that was globally that was available to anyone with an AWS account. So basically, anyone that and everyone had access to these 6 million emails, which contained government emails, university emails, just your average citizen email. And this is the breakdown. And it was left that way for 9 years before it was eventually detected. So it's not clear if it was ever utilized in such a way, but it was definitely compromised for a very long time due to negligence. And when you don't take data and security seriously, then the potential problems are just very detrimental, including loss of brand reputation, loss of future revenue, government-imposed fees, just to name a few. And this is all because of just an S3 bucket that wasn't configured properly. With Terraform, we're provisioning the entire application stack. Sometimes the application itself will be deployed as part of the deployment, and the secrets are everywhere. They needed to be everywhere because you're deploying to the cloud. So you're using API keys, you're using database passwords, you're using private encryption keys, and all of these are going to be managed by Terraform. What's worse is that due to the very nature of how Terraform was designed, many of these secrets appear as plain text in either Terraform, state, or log files. Now, everyone who talks about Terraform always mentions that state files need to be secured. And I agree with that. That's probably the first thing that I would do for secrets management is locking down the state file, making sure that that's not that you have it in a remote state store, something like that. But that's not the end all. Like, if you have your state in a remote state storage, that doesn't mean that you're totally protected against all avenues of attack. In fact, you have to consider about securing log files. You have to consider about who has access to merge pull requests into your repo, or even just make a branch and make a PR, not even merging that can be dangerous. Besides the obvious of state and log files, there's also the variables, which can be either static or dynamic secrets. So you have to think about how you're going to give your Terraform workspaces access to these different kinds of secrets, how you're going to, if there's static secrets, how you're going to rotate them, and dynamic secrets, what tool you're going to use to provision those secrets. And also, now you have to unify that across your Terraform deployments as well. And there's actually a couple of pitfalls with this that people may not be aware of, that in some cases actually static secrets could be better than dynamic secrets, just due to the way that Terraform works. And then finally, the last thing which is Sentinel and policy as code, which can definitely protect you for certain things, especially for bad configuration, using external data sources when you shouldn't be, nil resources and local exec prisoners. You can write policies to protect you from these kinds of things. And I really think that this is a very state-of-the-art view of secrets management or of Terraform, at least in the current state of things, based on a lot of research that I did when I was putting together this chapter. So I'm really excited to be able to talk about it today and really share some of these tidbits that even people that have worked with Terraform may be surprised to actually find out. So, securing the state file. This is actually the first thing that everyone always does, and the reason why is because the state file, as you already know, is plain text JSON. There's nothing secure about it at all. It's just a state file that's JSON, and you can't. And oftentimes you can't prevent secrets from making their way into the Terraform state file. It's there. It's out in the open. And if anyone has access to your state file, you can kiss your secrets goodbye. Now, there's 3 different ways that you can secure your state file. Number 1, you could just get rid of as many secrets as you can, which is actually surprisingly effective because there's a lot of secrets that people don't need in their Terraform state file that they're putting in there anyways. So when you're designing your workspaces, your new projects, you want to make sure that you're not putting yourself at unnecessary risk by putting in secrets that shouldn't even be there to begin with. Then you have least privilege access control, which kind of goes along with the remote state storage, that you want to have your state file somewhere secure and you don't want it on your local computer. You want to control who has access to that state file. And of course, for remote state storage, you want to make sure that it's going to be encrypted at rest and encrypted in transit. So let's talk about the first point here, which is removing unnecessary secrets from the state file. I can't even tell you how many people I know that they just put all the secrets that they have access to in a workspace without even thinking about whether they need these or not. So you should always think about what secrets you're putting in the state file and what isn't really needing to be there. And sometimes it's not obvious, but you may have to re-engineer some things, but it's definitely worth the effort. Because again, the fewer secrets you have in your Terraform state file, the less you have to lose in the event of a data breach. So in order to minimize the number of secrets in your state file, you have to know a bit about what can actually store stateful data. And I was actually this kind of changes from iteration to iteration, but currently the different blocks that are able to store information in your state file include resources, data sources, and output values, which I was actually a little bit surprised about output values because I didn't realize that output values actually were able to store information in state, but they do. And that's because you can use the Terraform provider as to get the outputs from other Terraform state files, which means that the output also has to be saved. So that was a little bit surprising, and that just goes to show you that you probably don't want to be putting anything too secret in the output values either. So besides these different configuration blocks, we still have the possibility of leaking information in other ways, but again, we're going to be talking about that later, so that's not the concern for right now. The AWS database instance is a very traditional example, I would say, because this is going to be part of most people's stacks, having some kind of database, and the minimal configuration for this database would be something that looks like snippet 12.1, in which case you have a username and password, and you set those probably through variables, and you think, okay, well, that's going to be good, right? Well, obviously, or maybe not so obviously, but the username and password, anything you set as an attribute for your database instance, so if this is my database instance, anything I set here is going to be passed also as an output. So it's not there, plus any computed attributes. So if these are my attributes, I can't even draw right now, then it also gets passed out here. So username and password are going to appear as outputs, and that means it gets saved into the state file. So for example, right here we have just a snippet of code that comes from a state file that happened to be created as part of this AWS database instance resource. And you can see that there's all these different kinds of things, but notably password is set and username is set. The rest of these are going to be either computed or other input attributes, but you can see that if someone just had access to your state file, then they're going to have access to your username, password for this particular database instance. And that may not be a problem, you think, but there's other kinds of resources that also could be, because what if your database was behind a firewall that you couldn't access it on the public internet anyways? Well, that's one form of protection, but again, you don't want to be making yourself more vulnerable than you have to be. So the state file definitely needs to be somewhere secure and not available to just anybody that wants to read from it. Less obviously is something like a AWS Lambda function. And for anyone that's used AWS Lambda function, it is a serverless function. It's a serverless function in AWS that lets you run code without worrying about servers. And notably here is that this would be considered like an application that runs, and maybe you put this behind an API gateway or something like that. Maybe you have some kind of event that triggers it. But let's say that this AWS Lambda function needs to be able to talk to the database that we created before. And we can't really avoid having username and password, as bad as it is to have these in a state file. We can't really avoid it. If you want this database and you want to create it with Terraform, you're going to have to accept the fact that password and username are going to be in your state file. For the AWS Lambda function, on the other hand, it doesn't necessarily need username and password set as environment variables. And in fact, I'm actually going to put a little red X here, because let's say you don't want that. There's better ways to be able to get information to connect to your database than by passing it as username and password and as environment variables. And the reason why is because anyone that has read access to your AWS Lambda function through the AWS console is going to be able to just see your secrets. So here's a screenshot from the AWS console, and you can see that you got read access to this Lambda function, then you're able to read password and username. There they are, Hunter2, and then admin, because apparently the other one didn't work. Now, I do not like to have my secrets exposed as environment variables. I think that is a very lazy way to do programming. I think that you need to, especially for your application layer, you should think more dynamically. You should think in a least privileged manner, so that the Lambda function should have an IAM policy that allows it to read secrets from some kind of secret store, but not be configured as part of the infrastructure deployment using environment variables. I think this is very bad, because not only does it show up in the state file, but again, it also shows up in the console, so that anyone that had access to read your Lambda function through the console would be able to see your username and password right there. One of the easiest ways to do this dynamic secrets provisioning is with AWS Secrets Manager, which is kind of a secrets management service that permits rotating, managing, and retrieving secrets. And GCP and Azure have their equivalents. And in fact, it's a competitor with Vault as well. I don't think it's as good as Vault, but it is definitely convenient if you're already working with AWS. And the way that you do that is you just give it an ID. So rather than passing in the username and password directly to the Lambda function, remember this is your application layer. So we're deploying the infrastructure, and then on top of that, we're deploying the application layer. So this down here is the infrastructure, and then right here is the application layer. So this may be unavoidable to have secrets, but the application layer definitely doesn't need secrets. It just needs the permission to be able to get those secrets from somewhere else. So maybe you have something like Vault, or maybe you have Secret Manager, but whatever you have a least privilege policy that allows the application to read from the Secret Manager store and then utilize that. And it's a dynamic secret. It's good because then you can enforce different kinds of policies. You can have rotation of secrets and so on and so forth. And if you were doing this with containers, it would be exactly the same, except maybe you would use like a container, a service mesh, instead of using a Lambda function with AWS Secret Manager. An example code, in case you were interested, of using AWS Lambda with AWS Secrets Manager, is a very, very simple one. This is written in Go, and I just declare the client. So this is the Secret Manager client that uses my credentials to talk to the Secret Manager with the ID that I pass in as an environment variable. And then here you can just print that secret, use it in some way. So now, as part of my infrastructure deployment, I'm not passing in the username and password. I'm just consuming the ID, and then I'm doing something with that ID. So that ties in very nicely with the next part, which is least privilege access control. Because remember, this Lambda function, the reason why that it works is because we're enforcing a least privilege policy. So that Lambda function is going to have something that says, okay, you can read this particular secret, but that's all you have access to. You don't have access to delete secrets or change anybody else's secrets or read anybody else's secrets. You only have access to read that one particular secret, and then we can handle versioning and so forth. So least privilege access control is definitely a good thing. You should always have least privileged for your deployments. In fact, one thing that I would recommend is when you're deploying Terraform for a particular workspace, you should try to use as least privileged for your deployment role as you can. You don't want to be using an admin role for deploying all of your workspaces to either AWS or GCP or whatever. You don't want to use an admin role, because then whoever has access to do a run on that workspace can deploy whatever they want. They can deploy EC2 instances that just appear for a short time and then mine bitcoins and go away. It's not a position that you want to put yourself in. You should consider what you want that deployment role to be able to do, and then do that. Now, I understand that's very difficult because Terraform hides so much from you. You know that it's going to do a create, you know it's going to do a read, you know it's going to do an update, you know it's going to do a delete. You may not really understand what goes into that. I did write a little program to be able to parse AWS providers and be able to, from your configuration code, it'll tell you exactly what permissions that you need. It's on my GitHub in case you were interested in taking a look at that. But it's not really worth the effort to go into super fine detail, just because it's not something that is really well supported right now by Terraform. However, for least privilege as far as remote state storage, that's a different matter. Now, we should always have least privilege policies, very fine-grained ones, in fact, for getting and setting state in a remote state storage. The example that we have here is for S3. Now, if you never used the S3 backend, it's just right here on Terraform. They tell you that you configure your backend in the Terraform settings block. You define a bucket, a key, a region, and then it uses a Dynamo database to preserve locking, and also uses KMS on the back end for encryption. Kind of complicated and rather long, and if you want to know how to create one of these, you can take a look at Chapter 6 in Terraform in Action, where actually I go through kind of what goes into this S3 module. And the ones for the different providers are going to be very similar in function. They're going to have a table for doing locking. They're going to have some place to blob storage to be able to put the state files, and then some way of encrypting it at rest. So when you deployed it, you want to also create roles for the people that are going to be consuming those consuming those state files and interacting with them in some way. So for example, you might create a policy that allows somebody to read S3 buckets and be able to put and get objects, maybe only from a particular folder in that Terraform state bucket. So if they were part of Team 1, then they could access the Team 1's state files, but they couldn't access other people's state files. And these S3 backends are so cheap that you might as well have one per each team and not even have to worry about creating some of these least privilege policies. But even if you weren't using S3, let's say you're using Terraform Cloud, there's still different ways that you can create least privileged on your state files, and also just in general access to your workspace. I think Terraform Enterprise does it pretty nice. You can create, they had a recent patch a couple months ago that allows you to create pretty fine-grained access control policies for your workspace, that you can say, like, if someone's part of a particular team, they have these permissions or not. You can blacklist and whitelist different users, and it's pretty fine-grained. I'm very pleased with how it turned out. The final part, as far as the state file is concerned, is that you want to enforce encryption at rest. So again, this is really something that comes already with most backends. You have S3, it's going to be encrypted at rest because of KMS, and you can define exactly what KMS key you want. You want to use your own KMS key, that's fine. But it should definitely be encrypted at rest, and sometimes you could even do a double encryption. I know that Terraform Enterprise does a double encryption where they use KMS to encrypt it once, but then they use Vault to encrypt it a second time. So that can actually make it very, very difficult to read state files that you don't have access to, even if you had admin privileges to the AWS account that the state files lived in. You still wouldn't be able to read them because it's gibberish unless you had both the KMS key that you can decrypt it with, as well as the vault token. So it's not very reasonable to assume that you could do that, and that would make it very safe for securing your state files. Also, just so you know, the Terraform Enterprise doesn't really do anything too much different than creating your own backend. In fact, their backend is actually is whatever cloud you're going to be using. So if you're using AWS, then they're also using S3 to store your state files. It's not any different than if you're using the S3 backend. But they do provide some additional tools that make it easy to interact with your state file besides just that S3 backend. In fact, I think that they have some their own custom logic built in. So it's not like they're exactly the same thing. And you don't really have to worry about encryption in transit because pretty much all of these providers, except for maybe the HTTP provider, are going to be transmitted over HTTPS, SSL, TLS, and so you don't really have to worry because they're going to be encrypting your data while it's traveling through the internet. Finally, one last thing I wanted to mention about Terraform and securing Terraform state files is that there's this people always ask this, why don't you just remove the secrets from Terraform state entirely? And this is something that's been tried in the early days of Terraform, where they would give maybe some provider or maybe some resource would define a encryption key that you could use to encrypt the sensitive information before it gets stored in the state file, and then it uses the encryption key again to decrypt it. The problem is that people would lose their encryption keys and then they would no longer have access to their infrastructure that they deployed. Also, it made it pretty difficult for calculating diffs of state, because if your encryption is not the same, especially if you're using different kinds of encryption keys, if you're rotating your encryption key, it's not going to be the same every time, which could cause some problems with Terraform, because what's stored in state is not actually what the information is. So they just did away with that, and now they assume that your remote backend is going to encrypt all data, and that's the recommended approach if you ask anyone from HashiCorp. I have heard that, they might bring something like this back eventually as part of the Terraform 1.0, but I don't even know how they would do that. I don't think they really know how they would do that. It's a very tough problem to solve because, ideally, if you could just remove all secrets from Terraform state, then you wouldn't even have to worry as much about where you store your state file or anything like that. But I would just still recommend caution and just good planning too. So if you're going to use Terraform state, just do it right from the beginning. Now that I'm done talking about Terraform state files, I want to talk about logs. And this is something that a lot of people don't even really think about. And I kind of find that surprising because to me, logs are just as important, if not more important, than Terraform state files. You can leak all kinds of sensitive information through logs, and I've definitely done this just through experimenting around and seeing what I can get from Terraform, how just so I can learn, and also so that I can exploit other people's and get their credentials when they don't want to give me their credentials. We have a public cloud team at my work that does not like to give some credentials in order to do your job. So you kind of develop workarounds to be able to get credentials, and you learn a lot of things by doing that. And one of the things is how to get it out of the logs, especially unsecured logs. And the way that it works is, let's say you have a machine that's running Terraform, you're deploying to AWS, information is going back and forth between your machine and AWS, and you can actually read some information from that log file that could give you credentials or some other piece of information that you could then use to make API calls outside of Terraform, and it would be using the same credentials that Terraform is using, so you wouldn't even know when you look into the logs why this is happening. So let's just take a look at a very, very, very simple example, which is the Hello World example of Terraform. We have an AWS instance, T2 micro, tag Hello World, and I just have that actually right here. So you can see I just have a variable, I have a resource, and I'm just going to Terraform apply that. So that's refreshing. Let me just make this a little bigger. So it's going to refresh state. So it's going to be doing the read operation, reading stuff that's on the back end. You can see that really nothing happened. And you're like, well, but if nothing showed up in my logs, then there's really nothing to be worried about now, is there? But actually, if I turn on the trace level logs, and then I'm going to run that again, then you can see that there's a whole bunch of information that pops up. And some people don't really like reading through this, but there's a lot of really good information here that a hacker or some other kind of malicious user could use to be able to get access to your workspace or to your AWS Access credentials. And let's just take a look at one of them, which is let me see here. I can't really see it super well. Is the get caller identity. So it tells you in the trace level logs exactly every request that you're making to AWS. So for example, just right here, you can see that it's making this post request to STS with this user agent, this content length. Here's the authorization that it's using to make that request. Again, this is all with the Golang SDK. And then you can see that the response was, the result is right here. And so you can see that my user ID is defined right here. So let's see here. This is me, and this is my account. This is my request ID that I made this request with. And you can actually forge, if you had access to this log file, you could actually forge a request as if you were the user. And what I've done here is just something real simple. I've gone to Postman and I've made a post request with the same information that was present here. You could also do this with a curl request, but you pass in the user agent, authorization, content type, date, and then the same all the same headers, and you can perform this request as if you were Terraform. And I think that's very interesting. Now, you think, well, that's not really a big deal, because who cares if you get the STS, get caller identity? That's not even a big concern. However, it actually works for all requests that you make and through Terraform. So if somebody was going to create an EC2 instance, then you could do that if you had access. So here's one for describing the EC2 instance. And so if I had, so here's the response right here. But if I made that same request with the security token and date and content type and authorization, then I could also use that as well. You could also do things like get VPC IDs and so on and so forth. So here is just me highlighting it again, and you can do the authorization. So this is really the red part right here is the dangerous part, because if somebody had access to that, then they would be able to make a request on your behalf in order to be able to get this kind of information. Now, what's good is that at least AWS knows that this could be a problem, so they do expire these requests, and so this isn't actually your secret access key or anything like that. It's a signature that's computed from your access key, and it's based on the time as well. So it's going to be only valid for 15 minutes. So even if someone had access to this, they would only have access to it for 15 minutes. And also, even if they had access to this, they wouldn't be able to go back and figure out what your AWS secret access key is just from that. And then here is just making that post request. Here's how that would work. So you can just, I did it in Postman, but you could just do that with a simple curl request. Here's the STS AWS access keys that you're getting, and you can get the get caller identity. And again, you could do it for any kind of request an API call that Terraform is making. So remember that AWS provider is going to be making all of these API calls on your behalf. So let's say that this is Terraform and this is the AWS provider. Then it's going to be talking to AWS and making all of these API calls: create, read, update, delete, hundreds, thousands if you have a big enough workspace. And any one of them, as long as you had access to log files, you could do something with that. I just thought this was kind of surprising, and really the main takeaway here is turn off your trace logging, because if you don't have your trace logging on, then you're not really going to be able to see this anyways. However, for some people, you kind of need trace logging for some things, so just be aware that trace logging does reveal additional information that you can avoid if you just are smart about it. Then you have local exec provisioners, and I absolutely love local exec provisioners, but maybe it's a love-hate relationship, because they are actually very dangerous. And in fact, you could make the argument that you shouldn't be using these at all, because they allow you to make commands through the shell on your local computer, and you can do pretty much anything with that. For example, you could print the AWS secret access keys if they were environment variables. So I have that just right over here. I have my AWS secret access key and my AWS access key, and I'm just going to print those, and I just have this trigger to run it always. So what I'm going to do is I'm just going to cd into this other workspace here. And I should probably turn trace logging off, but you can see here I'm printing the secret access key, and then here I'm printing the access key. I don't have them set. I should probably set them. But you get the idea. Let's continue on. So yeah, here it is where I actually did have them set. I have AWS access key, and then I have AWS secret access key right there, and these are just printed as part of the normal log. So in this case, I don't even have trace logging on, and I definitely recommend turning trace logging off. But just know that if you have a local exec provisioner, then you're able to print things without even having the trace logging on. Besides local exec provisioners, another really dangerous one is going to be the external data sources. And I just drew this little comic that I thought was pretty funny, that Terraform is trying to get information from JavaScript because it's an external data source, so it's trying to get the data from this external data source. But JavaScript is able to do malicious things while Terraform isn't looking. And I think that's just a perfect explanation of why I think that external data sources are just so dangerous. Now, let me show you the external data sources right here. It allows you to call any kind of code that you want, not even just shell code, but Python or Node, and you can actually return that information back to Terraform as a just to give you an idea of why this is so dangerous. Here is a little script that I wrote, that you have an external data source that is going to call this run.js script, which is defined here. And just one of the many things that it can do is it can get your AWS access key and AWS secret access key. And I know I keep using these, but it's just an example, a very easy one. I mean, we always want to make sure these are safe, but it can do things besides that. I mean, it could install software that you don't want to install, like keyloggers, or it could get other kinds of secret information from your computer. It could run any kind of scripts that you want, and you wouldn't even know, because when you let me just show you what this looks like. So I have a little Terraform right here that says do bad stuff, and I'm just going to turn off trace logging, and then I'm going to run this. You can see it doesn't even look like anything happened, but in the state file it has it shows up in the state file that your AWS access keys and everything. I didn't set them, but they if they were set like I have them set here, then you have the AWS access key equals this, AWS secret access key equals this, and there you have it. But that's not even the only place that it could show up, because also, again, going back to logs and why logs are so important, if I had the export log equal 1 and I ran this again, then something that a lot of people aren't even aware of when they're using this is that it also spits it out as a byte array. It's just a bunch of numbers that represent letters for that you can do things with. So let me see if I can try to find it somewhere buried in the logs. Well, I can't quite find it right now, but I have this JSON output, and this does show up in the log files, and you can see it's just a bunch of numbers, and you can convert this to a JSON string. So I just did that with this little utility function here that you paste in the byte array, and it converts it over to this. So and this is again could be avoided if you just had trace logging disabled, but it just goes to show it's another dangerous thing you should be aware of when working with logs, is that even something as that you wouldn't think of as storing secret information could potentially store secret information. And a bunch of numbers is definitely very innocuous. I think that external data sources are maybe the most dangerous of all resources, even more so than local exec providers, just because of their capability to do just about anything. That being said, I actually am a fan of these, being a hacker and breaker of all things Terraform. And I wrote this Terraform shell provider. This is a little self-promotion right here that I'm very proud of. And this one is even more powerful than the external data source, because it allows you to create not only data sources but resources as well. And you can create things with the shell provider, so you can define the environment, sensitive environment variables, and then you can define lifecycle commands for create, read, update, delete that are going to be called from Terraform on its normal create, read, update, delete. I am going to put this on the Terraform provider registry as soon as the Terraform 0.13 comes out. But a lot of people have good things to say about this. So if you want something besides the data source, then I would definitely recommend looking at this one. You can also, so we talked about the dangers of logs. So A, you can just turn off trace logging. B, you can try to avoid using some of these very nasty resources like shell providers and external data sources and local exec provisioners. But you should also concern yourself with just restricting access to your workspace in general. Like, you don't want people to do runs or applies against your workspace. You don't want to have trace logging on except when you're actively debugging. And also less obvious is that you want to make sure that people do not have the ability to make pull requests initiated from forks. And this sounds very specific, and it is, because if somebody can make do a Terraform plan triggered from a pull request, and this sounds like something you would normally want. Like if somebody wants to make changes to a repository, wouldn't you want them to make a fork of the repository and then make a pull request to merge it in and then run a plan to verify that their changes are good and not going to break anything? But if you run a Terraform plan based on their changes, then that means that you could actually run things like external data sources that you didn't even want, and you don't even know what's going to run through that script. And they might already have all of your secrets just from that one pull request, which you didn't even authorize because you had a Terraform plan that was triggered because of that. But just to be careful, just know what's possible, and just be on a lookout for these kinds of things. Most people are not going to do these different hacks and tricks and exploits, but just be careful, and just know that these are in fact risks, and you should be careful anyways. So now that we talked about managing state files and managing logs, for secret management, always talk about variables. How do you get variables? How do you set them as far as secret variables are concerned? And there's two different kinds of secret variables. You got static secrets and dynamic secrets. So static secrets are things that don't change, or at least they don't change very often. So you can set them either as environment variables, or you can set them as Terraform variables. And you have to know the limitations of their use, but also know that they actually are very safe as long as you rotate them on a reasonable basis, and then don't let things like external data sources and whatnot to print them. So environment variables. I am a huge fan of environment variables. I personally think that they are the safest way to pass secrets into providers for Terraform, because as long as there's only a few ways to be able to get environment variables, and we've already covered all of those ways. You can print them with an external data source, in the logs. You can put them in the state file maybe, but as long as you're securing your logs in your state file, they're very hard to get. And and then, as we'll discuss later with Sentinel, you can actually write a policy to prevent people from creating local exec provisioners that print things like that. And so then they're even safer to use. But the reason why I prefer environment variables is because regular Terraform variables are just so easy to get. You have this example right here that has an AWS provider configured with a variable for AWS access key and AWS secret access key. And you're thinking, like, that's not a problem, is it? But it is a problem, because variables are so much easier to get. Like, you don't even have to be... Some of these other kinds of hacks can be kind of tricky, and a lot of people wouldn't even think to do them. But for variables, it's so easy to get them. You can just output them, number one, using a normal output variable. You can also write them to a file using a local file resource. You can upload them to an AWS bucket. And these are just to name a few of the things that you can do with variables. And you can see it's so easy because you can just reference them like so. But because they're so easy, and you might accidentally put them as output variables, and remember, output variables get saved to state, I would just recommend not using them whenever possible. The only problem is that environment variables are really only supported for providers, especially like configuring secrets on providers. It's not you can't configure attributes like username and password on that RDS database with an environment variable. So even though environment variables, in my opinion, are much more secure, you're still going to have to use the Terraform variables regardless. Oh, and yeah, here's another thing about local files. I love the local file resource, and you can do all kinds of crazy stuff with it. One of the things that you can do is you can use the data source for the local file to actually read from any file on your machine, including your AWS access keys. So here I'm just using a local file to be able to read from my .aws/credentials file folder. And I hope that you get an idea of just how easy it is to be able to get Terraform variables where they in places where they shouldn't be. And there's just so many tricks. It's very hard to be able to protect yourself, which is, again, why I prefer environment variables over Terraform variables. So you can try to write sentinel policies to protect yourself, but because there's just so many ways that your secrets can leak, that environment variables are definitely the way to go. Yeah, again, here's just the example of the RDS. Like, you have to use username and password. You don't even have a choice to use environment variables, so good luck with that. Terraform Enterprise does allow you to set sensitive variables, which I like. And so you would use the UI to be able to set sensitive variables. If you are creating your own pipeline for deploying Terraform, you can insert sensitive variables anywhere along the line that you want. I mean, you can, before you initialize Terraform, you can go download a secrets.terraform vars file from some location and then have that already installed on the machine and use that. Or you could set the environment variables as you will. Sensitive, by the way, in regards to Terraform variables and Terraform Cloud, just means that you won't be able to read it after you set it. You can still, and it's also set as sensitive in the state, so they wouldn't let you read it from the state file. But you can still, there's still so many ways to get sensitive. So I think this word sensitive, as far as Terraform Cloud is concerned, is very misleading, because it's not, there's still a lot of ways to be able to read the actual value, even though it's marked sensitive. So it's better than nothing, but it's still not that great. Yeah, so if you are creating your own pipeline, a lot of people, what they do is they create a secrets.tfvars file, and then they'll have just their regular terraform.tfvars or production.tfvars, and then they can do a Terraform apply with both of those. And the secrets.tfvars might have gotten that from somewhere else. Like they might have downloaded that from the secret store. They might have any way that you want outside of Terraform, you get those secrets. I think it's a pretty safe way to do that when you're working with Terraform variables anyways. Again, I would still recommend using environment variables if you can. But if you have to use secret Terraform variables, then this isn't such a bad way of bringing them into the mix. And then just being smart about who you allow to make pull requests, what you allow to be merged, and so on and so forth. So, dynamic secrets. This is people do entire talks on just dynamic secrets, but I'm just gonna pretty quickly go through the general idea of how to use dynamic secrets with Terraform. The idea of dynamic secrets is that you want to take a secret and be able to rotate it as frequently as possible. So there really isn't a huge difference between a static secret and a dynamic secret, except the dynamic secret is just rotated very, very frequently. In fact, it should get to the point where dynamic secrets are only available once, and then that's it. So once they're used, then they're no longer valid. So that in that case, and they're created just in time, and they're revoked immediately after their one use. So these are called dynamic secrets because now they have to be rotated much more frequently, and you have to develop access control policies and such around them. The two big things, the two big services I would say would be Vault, HashiCorp's own Vault, and AWS Secret Manager would be another one, or just in the AWS space anyways. If you GCP obviously has their own one, Azure obviously has their own one, but just if you are an AWS user like myself, then your choices are going to be Vault because it's secure and also HashiCorp, and then Secret Manager because it's convenient because you're already using AWS. And they both pretty similar in the way that you use them as far as Terraform is concerned. And their deployment and things like that, it's a different matter, but let's just talk about Vault real quick. So Vault, everyone knows, very big product of HashiCorp. It's actually their biggest source of revenue, which I didn't know, but it is. They made over $100 million in they're projected to make over $100 million in revenue as of 2020, and it's what has brought the valuation of HashiCorp as high as it is. The way Vault works is you have some kind of identity provider that allows you to authorize clients, give them a token to be able to access secrets. So clients will talk to the identity provider. They'll get their access token back to them that they use to go. I just drew that everywhere, but they use their access. They use their temporary token to be able to access the secrets through Vault. And the way that you do that with Terraform is they have this Vault provider for Terraform that works just like any other kind of provider, where you define the provider, you define the address of where Vault is located, and then possibly other things like your what secret you want to get, which would be as the data source. So let's say you want to get your AWS access credentials. So you're going to want AWS as your backend and your role. And so this is going to read from our Vault provider. Not shown here is the fact that the Vault provider also needs its own authentication, because you have to be able to authenticate to your identity provider right here. And then we're going to present that. We're going to get our token, and then we're going to be able to use these access credentials to configure the AWS provider. So it's kind of a two-step process, and then now we have configured our AWS provider with access key and secret access key that were provisioned just in time, just for this particular deployment. And we can revoke them later as well. The reason why I don't like this is because, again, we have Terraform variables, not environment variables. Also, now for every deployment, you have to have this data source and provider, which are boilerplate. If you were running in your own CI/CD system, you might create this as part of some default configuration code. So you might have this as like your vault.tf file that's created automatically for you, but that's still not a very elegant solution. I don't think it's particularly good. I wouldn't do it. I still think that the static secrets with the environment variables, as long as you rotate them frequently, it's still a cleaner solution than this one. I know that as far as Terraform Enterprise and Terraform Cloud are concerned, HashiCorp is working to make this integration of Terraform with Vault a little bit more seamless, as I think they should. And the reason why is because there's really no difference comparing it with the AWS Secret Manager. So here is the AWS Secret Manager. So let's say that I got the provider AWS, and then I'm using the AWS Secret Manager version to get the secret, and then I decode that as JSON, and then I can use that down here. So the process is exactly the same, and it really shouldn't be. AWS Secret Manager is not. There's no reason why it should be easier to use than Vault, especially because Vault and Terraform are both created by HashiCorp, but it is. That's why I don't really think that Vault is super compelling to use with Terraform, at least not at the moment. So moving aside from dynamic variables and how to set those, there is Sentinel. And I've been watching Sentinel since it was first created, and it's finally starting to get to a point where I think it's useful. It wasn't very useful for a very long time. It serves a very distinct role of creating embeddable policy as code to automate governance, security, and compliance-based decisions. Basically, you can use it to enforce rules, and you declare the rules as code, saying things like you can't have a local exec provisioner that prints AWS access keys. That's not okay. So that rule would then be expressed as code. Another thing you could do is you could prevent someone from deploying, I don't know, like 5,000 virtual machines. And all of these have to be created, which is painful. But if you're in a large enterprise, it could still be worth it, because then, especially if you're not doing much enforcement for creating least privileged access keys for AWS or GCP, that someone might have the ability to produce this many machines without any oversight. Where Sentinel fits into the overall deployment scheme is that you have your GitHub repo and your source code for your Terraform, or whatever kind of version control you're using, which triggers a Terraform plan, which then triggers a Sentinel, and then triggers a Terraform apply. Now, plan could still be an issue, because remember, there are things that could run during the plan that are bad. I've talked to the Sentinel team, and they've proposed the idea of also putting Sentinel before the plan, but it's kind of hard because you can't really do too much. You'd have to write two separate policies, because one would have to run for before the plan just to analyze the configuration code maybe, and then this one would run based on other factors, like what the diff of the state is and so on. But currently it exists before the plan and the apply. So the idea is that you see if you're going to get what you want, and then you do a Sentinel. It's either going to say yes or it's going to say no. And if it's good, then it'll continue on to the apply. If not, then it's going to be rejected, and it's going to tell you why it's rejected. To give you some perspective on the history of Sentinel, it was created by Mitchell, and he created it probably in one night or maybe a weekend, and he just kind of left it there for a long time. It took a few years before they finally found a project manager and some engineers to be working on it full time. Now they got about 10 to 20 people working on it, and they're continuously making improvements. The recent version just added significant improvements to the Sentinel language. Sentinel, by the way, is actually its own language. It's similar to HCL, but it's not HCL. It's actually Sentinel. You can take a look at it on their website here. It works for all their different products, not just Terraform. Here you can see this is the one for Terraform that allows you to define a rule, and you can also write one for Vault. You can write one for Nomad. They don't support anything else besides their own products, which I guess is understandable, but it also limits the usefulness of it because it's not open source like Terraform or many of their other products. So you're not able to understand why something's not working. All you can do is you can just file a request that they add something, but you don't have the ability. It's not open source, and you're not able to extend it. And you're also not really able to use it unless you're using one of their paid products like Terraform Enterprise or Terraform Cloud. That being said, I don't think it's totally useless, because it actually is possible to use Sentinel even if you didn't have an enterprise license. You write these things called Sentinel plugins that are basically like Terraform providers, and what it allows you to do is read things like your state file, read things like your configuration code, and then be able to make decisions based on that. So you can read your configuration code and say, oh, well, I don't want someone to create 5,000 instances of resources, or I don't want someone to give a name for that's not valid, or I don't want to have anyone that has an open 22 port on production deployment, something like that. You write your policy, and then based against the configuration code, whether it's going to pass or not. The Sentinel binary you can just download. It is not open source, but the binary is still published. You can still download that. But there is this plugin that you have to use for integrating with Terraform. And because Sentinel is not a very popular technology, we just use the one that HashiCorp's created for reading configuration code and reading state files. But you could imagine that since all of their Terraform code is open source, that you could write a Sentinel plugin for doing exactly the same thing and publishing that as open source. And then you would essentially eliminate any benefit that Sentinel has for not being open source. And at that point, they might even be pushed to make the technology open source. I think that would be a very interesting experiment to see if anyone wanted to try that. But anyways, just moving on with what Sentinel actually is. It's just a very simple rule engine. So you have a rule. This is the most simple Sentinel policy you can make. You got main equals rule that returns true for all use cases. Well, that's not very useful, but you can imagine that we could start adding things to make it more useful. You could write a Sentinel policy to say, I don't want anyone that has this local exec resource with access key and secret access key to be able to work. So here is just a very simple policy, just to give you an idea of what is possible. I have this says, this rule here is what ultimately gets evaluated. So I say no access keys and no secret access keys. So no access keys is a rule that says not keyword in provisioner AWS access key. And so that's calling a function called keyword in provisioners. Again, this is all in the Sentinel language. That's why it looks a little odd. It's similar feel to Golang, but it's not actually Golang, and it's its own language. I think they just like creating their own languages for whatever reason. Now, the keyword in provisioner, so we got bad provisioners. So it's a sandbox language. So I guess it is very safe because you can't, there's no way to escape the sandbox, at least according to them. So here I'm filtering the provisioners. So tfconfig.provisioners, that's from the plugin that HashiCorp has written to be able to interact with their configuration code. And the tfconfig.provisioners allows us to read all of the provisioners on the Terraform workspace and then save that as a list of provisioners. Then I'm doing a filter on that saying if the type of the provisioner is local exec and the command matches S, meaning it contains that value somewhere, then say that it's bad. Otherwise, return true. And what this does is, if we were to apply this same Sentinel policy, which here's how you would do that. You just Sentinel apply p.sentinel, where p is my Sentinel policy. Then it fails because it says, oh, you can't do that. This this rule failed, specifically the no access keys failed, and then this failed. And otherwise, if you were to fix that, then it would return true. And again, you could use it for doing other kinds of things, like disallowing, allow all Cedar blocks, restricting various instance types, and even enforcing tagging on resources. So that's about it for the state of secrets management with Terraform. I hope you found that interesting, even if you are already a Terraform expert. Some of these things are not obvious, and it's just kind of surprising to kind of learn some of the edge cases and what you can, in different ways to be able to exploit Terraform, especially if you are like an administrator and you're responsible for designing the way that and policies, the company policies for how people use Terraform at your company. Then you want to know what the different tricks and hacks that people can do are. And I think that these are some of the most interesting and probably some of the ones that you should look out for in your own Terraform configuration code and workspaces that you manage. So my book is almost done. I'm decided I'm going to add a new chapter for the book, chapter 13, and I'm going to be talking about module expansions just in time for Terraform 0.13. My book is scheduled to be in print by October, maybe November. So it's been an exciting journey. I really hope that you like the book. And if you haven't already bought it, you can use the code TS Terraform to save 50%. Well, thank you again for your time. And until next time, bye.